This chapter will be a basic skills review. In this lesson, we're going to look at rates and ratios.
Hi everybody. So in this lesson here, we're going to take a look at rates and ratios. And we're going to start off by looking at ratios. Okay, like it says here, a ratio is a comparison of one number to another with the same units. So when we compare them, we're not even concerned about as a fraction here. Maybe you would have A centimeters over B centimeters. The centimeters would cancel because I'm not really comparing the units. I'm comparing the values, the size of the number with the size of the other number. And so you can express that ratio in two different ways. We can go A colon B, okay, quite a bit, or A over B in a kind of a fraction form. So let's just take a look at a couple of examples here. So consider the friends Rachel and Sarah. They decided to keep track of how many texts they're going to send per day for 3 days. And so here's their findings. Okay, so here we go. And then for Sarah here, 23, 40, and 54. So the first question here is write the ratio in reduced form of the number of texts Rachel sent on Wednesday to the number of texts Sarah sent on Wednesday in both forms. So A to B and then A over B. Okay, well, so what we got here is we're going to do Rachel, and that's going to be 81. Rachel sent 81 on Wednesday and Sarah sent 54. So that'll be 81, colon 54, or we might write that as 81 over 54. Okay, now let's take a look here. Now, immediately what I see here is I see that both of those numbers here can be written as a factor of, a product or multiple of 9, I should say, multiple of 9. 9 times 9 is 81, times 6 is 54. So 9 times 9 is 81, 9 times 6 is 54 here. And so I can divide both sides of that ratio there by 9, or both sides of the colon really by 9, to get a 9 to 6. Or here, 9 divided by 9 is 1, and I get 9 over 6. And I think, well, wait a minute, both 9 and 6 are multiples of 3. So 3 times 3, 3 times 2, and I can divide both sides by 3. Here, 3 times 3 over 3 times 2, and again, those 3's can cancel. They become 1, and I'm left with 3 divided by 2. Okay, so 3 to 2, or 3 over 2. Two different ways you can write that same ratio there. Now, the next question here says we're going to write the ratio in reduced form of the number of texts to the number of texts that Rachel wrote on Wednesday, and both forms here. Now, this question looks really, really similar. In fact, when I first read through those two, I had to just read it again to make sure that I understood what was going on there, because there is a difference to what we just saw. In the previous case, Rachel was the first one, and we were comparing Rachel to Sarah. Now we're taking Sarah, the amount that she texted, which was going to be 54, to Rachel's 81, or 54 over 81. And now I already know that I can take out like a 9 and then a 3 here, and I would get 3 and 2. But it's just that my ratio is going to be the other way. Instead of being 3 over 2, it's now going to be 2 to 3 over 3. Okay? So we can do the same sort of simplification, whether we write the ratio in as a form like this with the colon, or in the form of a fraction. Right, now let's take a look at something called a rate. Now, a rate is very, very similar to a ratio, except that here we're going to be comparing two quantities with different units. So now the units become important. So it's not just the size of the number, but it's the unit that we associate with the number that's going to communicate some meaning. When we're talking about ratios, I'm just comparing values, how big one quantity is to another here. I don't really care about the units, because the units are going to be the same, right? So it's just comparing values. Here, slightly different here. So let's take a look at an example. Rachel sent 165 texts in 3 days. Okay, well and we want to express that as the total number of texts Sarah sent over 3 days as a rate. Well, that's like 165 texts, okay, per 3 days. So we're just going to include the units here. Or 165 texts per 3 days. So here's my rate sort of expressed in two different ways as a ratio, but with units. Now, typically wouldn't leave it like this. We typically go one step further and reduce that to get something that we call a unit rate. But we're going to take a look at that in just a few moments here. So we're going to leave it like this just for right now. Now, you can also use proportional reasoning to solve problems using rates. And people do this all the time. Okay, so what we're going to do here is put the given rate on the left-hand side. So we're going to set up remember, with a proportion. With a proportion, we've got A over, remember that we've got that tool, that cross multiplication there tool. So we're going to put the given rate on the left-hand side. So this is going to be the thing that we know. Okay, we're going to label the rows with units. Okay, so we want to make sure that we've got the same units in the numerator, same units in the denominator. And then place the given measurement on the desired rate on the right-hand side, matching its unit to the appropriate row. So whether it's in the numerator or denominator, that's going to depend on the choice that we make over here. And then the one that we don't know, there's our unknown, and we're going to cross-multiply and divide to solve. So let's take a quick look here. So from before, if Rachel continued at the same rate, how many texts will she have sent over 1 month, which would be 30 days here? Okay, well, we already know she is doing 165 texts in 3 days. Okay, so this is going to be the left-hand side of our proportion here. On the right-hand side, I know how many days we're talking about. We're talking about 30 days. So what we're going to do here is I'm going to put 30 days in the denominator so that I've got days on both sides in the denominator. I mean, that just makes it consistent. It's going to be equal. And so this is going to be X texts. I don't know how many there are, so I'm just going to use the variable X to represent the number of texts. And now we're going to cross multiply. Okay? And so we're going to get 165 times 30. Okay, which is going to be, again, maybe I'll write it out like this. We're going to get whoops. I don't know why I wanted to do that, but here, I'll get rid of that. Oops, there we go. So that'll be 165 multiplied by 30. And this is going to be texts times days. So it'll be 3 days times X texts. Okay? So X is still going to refer to the number of texts here. Now, 165 multiplied by 30 is 4,950. Okay, and that's going to equal 3X here. Now, to get the X by itself, what I need to do is I need to divide both sides by that 3. I need to get rid of that 3 there. On the right-hand side, the 3's cancel. 3 divided by 3 is 1. And it's just going to leave me with an X there, 1 times X. So X. And 4,950 divided by 3 is 1,650. So what that means is, over the course of a month, we would expect her to send 1,650 texts. Okay? Now, let's take a quick look at another one. Whoops. There we go. So, Jen is painting her house. She can paint 2 rooms in 5 hours. So there we go. We've got a comparison here. 2 rooms in 5 hours. So let's set that up here. 2 rooms, hours. So there's the left-hand side of the proportion. I don't even have to read the rest of it to know that this is what I'm going to be working with here. How long will it take her? So how long? So it's the time here. So that's what we're not going to know here. X hours. And I'm putting hours, the X in the denominator, because that's where my time was over on the left-hand side, I should say. How long will it take her to paint all 7 rooms in her house? 7 rooms. Room to hours, room to hours. So now we cross multiply. 2 times X is 2 times X. Because I don't know what the X is, I can't do anything about that. 5 times 7 is going to be 35. Okay? And now I'm going to take both sides here and I'm going to divide by 2. So on the left-hand side, the 2's are going to cancel, so we're going to get X. And remember, X hours, those are the units there. And then 35 divided by 2 is going to be 17.5. hours. So we would expect that it would take 17 and a half hours for her to paint all 7 rooms. Now next, Brianna's chocolate chip cookie recipe will make about 3 dozen chocolate chip cookies. The recipe calls for 2.5 cups of flour and a half cup, it's not a half, wow, of baking soda, okay, which is quite quite a big change from the half that I was going to say here. So if Brianna were to adjust the recipe to include 1 cup of baking soda, how many cups of flour would she need? Okay, so don't get thrown off by this 3 dozen chocolate chips. That extra information that I don't actually need to answer this problem. What I need is the rate here, and I've got 2.5 cups of flour and 0.05 cups of baking soda. So 2.5 cups. Now, I realize that we're dealing with cups and cups here, but this is cups of flour over 0.05 cups baking soda. Okay? I was actually going to shorten that down to BS, but I thought better of it. Actually, I suspect that there might be a typo here, that probably was intended to be 0.5 cups of baking soda, but I think it's kind of funny and it's going to make the number quite big, so I'm going to stick with it. I'm just going to stick with it. So if Brianna were to adjust the recipe to include 1 cup of baking soda, which is going to be a huge jump up from 0.05 cups. Like I said, I think there's a typo there. 1 cup baking soda. And the question is, how many cups of flour? I expect this is going to be huge. So we're going to cross multiply. Now, I like this. I like the 2.5 times the 1, because it's going to be just 2.5. And then this is going to be 0.05 multiplied by x. X is going to be cups of flour. So I have to divide both sides by 0.05. So on the right-hand side, the 0.05s are going to cancel. Yeah, this is going to be entertainingly large. 0.05 here. Yep. 50. Okay, so she is going to need 50 cups of flour. Okay, which, I mean, that's, if that is really what's going on here, clearly we're making like this cup, we're making cookies for an army here. So anyway. Okay, now we're going to take a look at unit rates, okay, or a base rate here. And when you know you're looking at a unit rate when the denominator is 1 unit. So it's going to be some value, some number of units per 1 unit. And it's a nice kind of standard way of dealing with relationships between things. People do this a lot. People do this kind of math here a lot when you go shopping, because you're trying to figure out what's the best deal. The easiest way to do that is to reduce the values, like money per gram, or money per milliliter, or whatever, something like that, so that you can figure out what the best rate is when you're out shopping. Anyway, so from before, what is the unit rate of Rachel's texts? Now remember, that was 165 texts in 3 days. So 165 texts in 3 days here. And we left it like that. But 165 and 3 have a factor in common. They both have 3 in common. If I take 165 and divide it by 3, I get 55. So this is 55 times 3. I've just rewritten 165 as 55 times 3. It's the same thing. Over 3 days. But 3 divided by 3 cancels, becomes 1. And so I'm left with 55 texts over. Now, don't get caught making this little error here. The 3 canceled. 3 divided by 3 is 1. Or better yet, 1 over 1. Okay? So 1 times 55 is 55, but there's still this 1 in the denominator not 1 days. Oh boy. 1 day. Okay? But don't make the mistake of putting a 0 down there. Okay? That would be incorrect. Okay, when those numbers cancel like that, it's because they're producing the value 1, not 0. Okay, let's take a look at another one. From before, how many hours does it take to paint one room? Okay, well now I got to go back and figure out that room thing here. So the question said that she did 2 rooms. Oh, sorry, it says it right here. 2 rooms in 5 hours. 2 rooms in 5 hours. Okay, so in this particular case, notice that the 2 and the 5 here are both prime numbers. They don't have any factors in common. So when I try to force a 1 into the denominator here, okay, I'm going to get a decimal value. In fact, if you're not quite sure what to do with this, maybe what you want to do is we're going to put X rooms here, and we're going to force this to be 1 hour. If you're not knowing how to simplify this right off the bat here, in the previous question, what I did is I took the numerator here and just divided it by the denominator, which makes sense. It's easy to do when there's a common factor there. I can just cancel that denominator out and away we go. Here, maybe not so much. So I want to cross multiply 2 times 1, and it's going to be 5 times x. So 2 is equal to 5x. Okay. Then I'm going to divide both sides by 5. Because remember, I want to get the x by itself. It's 5 multiplied by x, so I got to get rid of that. So 5 divided by 5 is going to be 1 times x is x. And then 2 divided by 5 is going to be 0.4. And this is one of those cases here where actually I'm better off using the decimal here. So what that means is she can do 0.4 of a room per 1 hour. Okay. Okay. Basically every hour she can do about 40% of a room. At the grocery store. So here's a pretty practical example. Ali finds a bag of apples that cost $7.99 for 3 kilograms. What is the unit price per kilogram? Okay. And so this is a good question here. So $7.99 per 3 kilograms. Okay. Now, once again here, these are not going to divide out very nicely. Okay. So I know I'm going to get some sort of a decimal here. I could cross multiply. Okay, I could totally cross multiply here, but I already have kind of a sense of how this is going to work. Let's go back here. In the first question that I did on unit rate, and I'm just going to grab that again here. The first question that I did, I took the 165, just rewrote it, and then canceled the 3. I divided by 3. I took 165 divided by 3, and then I got my unit rate. In the next question, I didn't do that. Decided I was going to set this up a little differently, and I was going to cross multiply. I probably should have done that too. Cross multiplied and divided. But notice when I did that I ended up with 2 divided by 5 that I had to do. 2 divided by 5. That ratio up here popped out again in my work. So when I get to this question here, well, I'm starting to think that maybe I should just cheat just a little bit here. I know it's going to be $7.99 divided into 3 kilograms. And when I take $7.99 and divide it by 3, I get $2.66, roughly. There's a little bit of rounding there, but that's what it's in 66 cents per kilogram. Okay? And now finally, this one here, the ratio of oil to vinegar for a salad dressing is 2 to 1. If a recipe calls for 6 cups of dressing, how many cups of oil and vinegar does the recipe require? Okay, so here we've got a slightly different sort of a problem here. So the ratio of oil to vinegar for a salad dressing is 2 to 1. Okay, the recipe calls for 6 cups of dressing. Okay, 6 cups of dressing. So how many cups of oil and vinegar does that require here? Now, watch this. You've got 2, oil. 2, actually, I'll write it out as cups. I've kind of been in my head thinking, how am I going to write this out here? But we'll do it like this. 2 cups oil to 1 cup vinegar. Now, what's going to happen here, and this is sort of interesting here, but what's going to happen here is, bear in mind that over here, it doesn't say 6 cups of oil. It doesn't say six cups of vinegar. It says 6 cups of dressing. Well, if I've got the ratio 2 to 1, 2 cups to 1 cup, altogether, that's 3 cups. That's 3 cups of dressing. Okay? So what I'm going to do here, and this is one of the nice things about when you're working with a unit ratio here, which is sort of what I've got here, 2 to 1. Okay? What I can do here is I can just very easily multiply this by the multiplication factor here. If I want to go from 3 cups to 6 cups, I just have to double the recipe. So basically what I'm going to do is I'm going to multiply by 2. So my 2 cups of oil become 4 cups oil. But now remember, I want the ratio to stay the same. I don't want to change anything. So what that means, I'm going to multiply my denominator by 2 as well. So that becomes 2 cups vinegar. And that is actually exactly what the question is asking for. How many cups of oil and vinegar does the recipe require? So in the previous questions, we were taking a scenario and reducing it to like a unit ratio or unit rate. Here, we've got the unit rate basically. And I just want to expand this up so that I can deal with a larger mixture here. I hope that helps.